Hey everybody, this is Mr. Beckstrom, today we're going to go ahead and take a look at applying a derivative to this function here. The function is 4x times the quantity x raised to the fifth power plus 1 all raised to the seventh power. So let's take a look at how we should accomplish this. So the first thing I want to see is what rule would encapsulate this entire function here. Now, we might say, well, that's definitely a chain rule part here. But the chain rule only applies to this part right here. So if we were to apply the chain rule, we'd still have this 4x that we would have had to have dealt with. So we really need to pick a different rule that encapsulates the entire function. And we can see that we can really write this as 4x times this quantity here, the x to the fifth plus 1 all raised to the seventh power. So we can start off with the product rule, and then while we're applying the product rule, we can see that the chain rule is going to have to be used as well. Now, if you'd like to go ahead and do the chain rule off to the side first, I would suggest that so that way when you're working the problem, you can go ahead and quickly substitute that derivative of this function in there. So let's do that. So off to the side, I just want to say, all right, what is the derivative with respect to x of that second part of it that we're going to use later in our problem? So x plus 1 raised to the seventh power. And here, again, it's just a chain rule problem because we have a function raised to a power, so we can do the derivative of the outside function times the derivative of the inside function here. So if we're taking the derivative of the outside function, we keep the inside function the same. We apply that general power rule, bringing the 7 out front, and then we still have the inside intact, x to the fifth plus 1, and then we have to subtract 1 from the exponent, so 7 minus 1 is 6. And then we're going to multiply that by the derivative of this inside function. We can use the sum and difference rule just to do these separately. The 1 is just going to zero out. So we just have to take the derivative of x to the fifth, which applying the power rule is just 5x to the fourth. So times 5x to the fourth power. And then we can kind of make sure that's times there. And then we can go ahead and combine that, simplify it a little bit. So this is going to be 35 x to the fourth, x to the fourth. That's combining the 7 and the 5x to the fourth. And then that's going to be times x to the fifth plus 1 raised to the sixth power here. Alright, so again, I did that part off to the side so that way I can use it when I'm applying my product rule. So let's go ahead and do the product rule. So remember, the product rule is the first function. We'll call that number 1 here, and this one number 2. So it's our first function, 4x. Let me give myself actually a little bit more room here. So it's our first function, which is going to be 4x times the derivative of our second function. Luckily, we thought ahead. We worked that derivative off to the side, so we already have it. So this is going to be times 35 x raised to the fourth power, and x plus 5, x plus 5, all raised. And this is raised to the fifth power here, and this is all raised to the sixth power, like this. Okay, and then we're going to add the second function using the product rule. So that's just x raised to the fifth power plus 1 raised to the seventh power. So this function here times the derivative of our first function. Derivative of 4x is just 4, and it's going to look like this right here. So the last thing, this is correct if we were working this on an exam. You would get full credit for getting this far right here. If you want to clean this up a little bit, looks like we have two terms. We have this big term and this term. We have an x to the fifth plus, ooh, sorry, that should be a 1 there. X to the fifth plus 1. We have that twice. We have it raised to the sixth power here, the seventh power over there, and then we have a 4 in both terms. So I can pull both of those out. So that would be 4, and then take the smaller of those. That's going to be x to the fifth plus 1 raised to the sixth power. And then what I have left is, in this function here, I have an x and a 35x to the fourth. So this would just be 35x raised to the fifth power. And just make sure that's right. And then that takes care of all of that. And then we'd have plus. We have one more of these. So x to the fifth plus 1. And that should be it right there. Let me just make sure everything got put in there. Alright, 4's been factored out. All right, if you have any questions, let me know. And I hope you have a great rest of your day. Thanks.